In the previous module, we looked at how some basic statistical concepts can be applied to climate data. These include the concepts of a normal distribution, or bell curve, the mean, and the standard deviation. We also emphasized the importance of focusing on the trend rather than the variability in a time series of climate data. In this module, we'll have a look at the spatial variability of temperature data on a global scale and how this is related to some extreme events. Here we're looking at a map of the world showing temperature in August 2003. In August 2003 was about 0.69 degrees Celsius warmer than the average August in the 1951 to 1980 base period. But this additional heat was not evenly distributed across the surface of the planet, and the Earth's weather systems rearranged this additional heat into warmer and colder air masses. In the summer of 2003, we were under one of those warmer air masses, between about 1 and 4 degrees Celsius warmer than August in the base period, and that had consequences in Western Canada. That summer, the summer 2003, was one of the worst fire seasons on record in the province of British Columbia. There was a much more devastating heat wave in the summer of 2003, and that was centered right over France and affected a number of European countries. And what we're looking at here is a bell curve of Swiss summer climate, showing 100 years of Swiss summer temperatures, and the green curve is the bell curve for that data. And you can see that the summer of 2003 fell off the end of the historical bell curve for Swiss summer temperatures, and this had enormous consequences in the region. There were approximately 70,000 fatalities that were directly attributed to this heat wave, and the loss of something like 13 billion euros from the agricultural sector. Now we're looking at December 2010, which was about 0.48 degrees Celsius warmer than December's in the 51 to 80 base period. However, Western Europe and the UK was hit by a significant cold wave, and this made international headlines. There was snow in London, and Heathrow Airport was shut down for a few days. And December 2010 was about 5 degrees colder than December's in the historical average. However, all the international press coverage of the cold wave in Western Europe managed to miss the monstrous heat wave that was occurring simultaneously in the Canadian Arctic. The National Oceanic and Atmospheric Administration released a statement, however, that noted that between the 17th of December 2010 and the 15th of January 2011, the largest temperature anomalies here exceed 21 degrees Celsius above average, which are very large values to be sustained for an entire month. And Iqaluit Nunavut experienced rainfall and above zero daytime highs in early January 2011. Now we're looking at a map of the world showing temperature in July 2010. And July 2010 was about 0.58 degrees Celsius warmer than your average July in the base period, 1951 to 1980. But in our part of the world, temperatures in July 2010 were a little bit cooler than the average July in the base period. However, a very warm air mass settled over the Moscow region, western Russia, and this caused all kinds of problems in that part of the world that summer. And here's a bell curve showing July temperatures in Moscow since 1950. And again, you can see that the summer of 2010 was off the tail of the historical Moscow July temperature bell curve. And there were approximately 56,000 fatalities associated with this heat wave, a loss of about $15 billion from the Russian economy. And about a quarter of the Russia's grain harvest was decimated by this heat wave. And approximately 750,000 hectares burned in the central and western part of the country in summer 2010. Skipping ahead to November 2016, we can see that was a very warm month in this part of the world. November 2016 was between 4 and 10 degrees Celsius warmer than November's in the base period. And November 2016 was the third warmest month in the Edmonton temperature record. Now what I want to do is just emphasize how quickly this can change, and if we advance forward 1 month and look at December 2016, we can see we have the opposite situation, and it was between 2 and 4 degrees colder than the average December during the base period. And it snowed in Vancouver in December 2016, and I recall there were questions about what had happened to global warming. Did it stop? Did it go away? But it didn't stop, although there was local variability. Globally, December 2016 was 0.84 degrees Celsius warmer than December's in the 1951 to 1980 base period. I'd like to finish this module up with a comparison of global temperature maps with November 1977 on the left and November 2017 on the right. November 1977 was 0.16 degrees Celsius warmer, and November 2017 was 0.87 degrees Celsius warmer than November temperatures during the base period. So there's a lot more red on the November 2017 map because global temperatures over the last 40 years have been going up. The planet's weather systems rearranged the atmosphere into cold and warm air masses in the past, and you can see that there was a heat wave in Siberia and a cold wave in Alaska in November 1977. This spatial variability will continue and will result in both hot and cold waves in the future. However, with additional heat in the system in the coming decades, it will become more and more likely that conditions that are off the hot tail of the historical temperature bell curve will occur at any given location on the planet. This wraps up Module 2 of Climate Change in Alberta, Spatial Variability.